Hello guys, in the previous lecture we talked about linear regression. Now in today's video we'll be talking about gradient descent. So gradient descent is actually the basic, or we can call it the foundational stone of the all the machine learning algorithms that we'll be looking into, and how the convergence happens, how the neural network learns, and all that. The whole fundamentals depend upon the one concept that is called gradient descent. So we had talked about gradient descent in the previous video as well, but in this particular video we'll get into the in-depth of the gradient descent and how it helps to minimize the cost function. And in the previous video we saw that the cost function was j of theta naught comma theta 1, and this was basically for when the hypothesis was theta naught plus theta 1 times of x. So basically we have two parameters that we have that are the trainable parameter, and based on these parameters you have to fit a function such that these values are such that theta naught and theta 1 are such that your cost function is minimum. That is what you want. You want minimize j of theta naught comma theta 1. Okay, now how would you start? So first pipeline would be, you can start with, so first you'll have to start with some random value of theta naught and theta 1. Let us say you'll start with theta naught is equals to 0 and theta 1 is equals to 0, and then you'll keep on changing the values of theta naught and theta 1 to reduce j theta naught comma theta 1 until we hopefully end up at the minimum. Okay, so if you want to write it in form of an algorithm, we'll say gradient descent convergence so we can say we need to repeat certain step. So this will be a recursive step, a loop, which is basically theta j is equals to theta j minus alpha times of del over del of theta j of theta naught comma theta 1. So how you change the value of theta j? You assign an initial value of theta. So theta j would be j can be 0 or 1 as in the previous situation, and then you'll initialize it with certain value, and then you'll keep on changing the values based on this equation. Okay, so basically you're finding the gradient of the cost function with respect to that particular theta value or the parameter, and this is a certain value. It is called as learning rate. You might have heard of it, which is a very important hyperparameter which helps converges, and theta j is equals to theta. So this is not equals to, this is basically this sign, which means assignment. That is, with every iteration you'll update the value of theta j and then perform the whole iteration again. Okay, so by this you will simultaneously keep on updating the value of theta naught and theta j using this assignment statement. Okay, so that is one thing. And so what is the relevance of learning rate? So learning rate is basically important because it helps us to understand, or to basically you can say that controls the step size in which the values of the theta j changes. Okay, and so by keeping the learning rate as small, it converges the value or get us to the minimum value in a longer duration of time, but it also ensures that it doesn't stick or get stuck over some local minima. So it's a very important to understand learning rate, and learning rate is a hyperparameter which you can tune and see if our algorithm can fit even better or not. Okay, so this is something. Now also we need to understand one more thing. Like here we have two hyperparameters, that is theta naught and theta 1. So how would you update the values of theta naught and theta 1? So there are two ways to do it. One would be, since you are finding the partial derivative of say for theta naught, you are passing the finding the partial derivative of the cost function with respect to theta naught, right? In that case, the value of theta 1 would be something in the cost function. So would you update it simultaneously, or how would you do it? That need to be understood very well. So suppose we say temp of, or this is a temporary variable, say temp 0 is such that equal to theta naught minus alpha times of del of theta, del of theta del of j of theta naught comma theta 1 divided by del of theta naught. Okay, this is the first value with respect to theta naught. Now we say temp 1 is such that equal to theta 1 minus alpha times of del j del theta 1 or theta naught comma theta 1, and then finally you'll say theta naught is equals to temp 0 and theta 1 is equals to temp 1. That is, you'll find the updated value for all the parameters first and then you'll assign it. Okay, this is one way, and it is like you are simultaneously updating it. Okay, simultaneous it is. Now there is another way to it. What could be the another way? Another way is you'll find this value after calculating it. Just after this step you'll say theta naught is equals to temp 0, and after that you calculate this particular value and then you say theta 1 is equals to temp 1, which is a wrong way of assignment. So basically you have to find the updated value of parameters in first and then you do the assignment and then you iterate over it again. Okay, so let's understand it. Like this was the basic understanding of how you update the parameters, you use the learning rate, you use the derivative in order to determine what would be the change in the value of it. But how all this works, okay, let us understand. So basically, as I told you, the whole phenomena or whole idea of gradient descent is simple. This repeat theta j is that equal to theta j minus alpha del by del theta j of theta naught comma theta 1. Okay, so this is the overall idea to it. Now how does this works? Okay, so let us see it graphically, like how this basically works. Okay, so suppose this is the cost function that we have. Once again, suppose this is the cost function that we have. Okay, that is, this is the cost function with respect to theta 1. Okay, and this is the value of theta 1 and this is basically the value of j, and this is the cost function that we have. So at any point in this particular graph, say here if you would plot a tangent at this particular point, how the tangent would look like? It would look like something like this, right? So here if you see, it is basically a positive slope. And when we learned about derivatives, we know that del j over del theta 1 is basically nothing but slope, right? So what will happen when you update that particular value, that is theta 1 is such that equal to theta 1 minus alpha del j over del of theta 1 theta naught comma theta 1. This is basically the slope of the of j value with respect to theta 1. Okay, and this at this particular value of theta 1, you say that your slope is positive. If the slope is positive, this value would be positive, right? And learning rate is a positive value, right? So what it will do, it will do theta 1 is such that equal to theta 1 minus some positive value, right? So this will basically reduce theta 1, and theta 1 will move in this direction, that is it in the direction of minima. So here somewhere it would be the minimum value. And similarly, if you suppose, now let's say in the same graph your theta 1 was somewhere here, you started off from here. So here if you will check the slope, the slope will come something like this. Okay, so this here if you see, this is a negative slope in this with this angle. So this is a negative slope. In this case, what will happen? In this case, for this theta 1 is such that equals to theta 1 minus alpha times of del of j of theta del of theta 1. This particular value would be a negative value, right? So it would be theta 1 is such that equals to theta 1 minus alpha times of some negative value, such that, so this will lead to the reduction in the value of theta 1, right? So in this case your theta 1 will move in the direction of again towards the minima. So this is how this particular slope variable manages and help us to converge towards the minimum, right? And also we need to keep one more important thing in mind, that this thing, that is the learning rate. If the learning rate would be too small, right, this is the learning rate, and the learning state it is very small because this will get multiplied with the slope, and by the order of this the value of theta 1 will either increase or decrease. If the learning rate would be very small, your gradient descent will be slow, and if the learning rate is large, the gradient descent can even overshoot the minimum point or even diverge, right? If you say that this is a very large value, alpha is a very large value, then probably that here it is a positive slope and your theta 1 value get reduced in such a way that it moves till here, directly from here till here. So it has overshooted and gone even beyond the minimum value. So that is why, and then it will keep on oscillating. Then here the slope will become negative, again it will overshoot and move here, and then again it will overshoot and move here. So in this way it may keep on oscillating. Thus you need to carefully determine the value of learning rate. Okay, also there might be cases where due to the value of theta 1, for a certain value of theta 1, and your cost function might not be a simple straight graph as we saw earlier. It could be something like this graph. Okay, in this case, suppose here your slope becomes 0 and this is a local minimum, and let's say your global minima was, say it was like something like this, and this is your global minima and this is there, and here Here particularly your slope is equals to 0, which is basically the local minima, and as slope becomes 0, what will happen? Theta 1 will be equal to theta 1 minus alpha times of, let's call it, slope. And if the slope value will become 0, this will become 0, and thus theta value will remain same. It will not get updated, and thus gradient descent can also converge at even local minima, even when if you make alpha to be fixed. Because see, if let us say that if the alpha is fixed, you are not moving the value of alpha, and there's no change in the value of alpha value, or or let us say you are taking it to anything. Okay, what will happen? Let us observe this function. Let us say this is the cost function. Forgive my drawing. Let us say this is the cost function. Okay, then value theta 1 is equal to theta 1 minus alpha times of del j of theta 1, del theta 1. In this case, you see that here, suppose your theta 1 value was here somewhere. Okay, this is the cost function and this is theta 1. Your theta 1 value was here somewhere. Here the slope is high, and let us not even consider here the learning rate. Here your slope is high, this value would be high, and thus theta 1 will get reduced by a larger value. And suppose your next, after getting reduced, it moves to here. This is your value. Here again we'll follow the iteration. The slope will be lesser than as compared to this point. It will move lesser value, suppose here, and here again lesser than compared to previous, again this much. So here you see that the distance moved will keep on decreasing, right? Because the slope value will keep on decreasing. Thus, even if we keep the value of alpha constant, so there is a concept which says that by time we can keep on decreasing the value of alpha so that it converges better. But even if we keep the value of alpha constant, then also it will converge because the value of the slope will itself change. Okay, so basically this is the overall understanding of what is gradient descent, and this is how most of the algorithm that you will see later, how it converges. And there are various optimization algorithm that you will see later, how does this help the gradient descent to converge even better. So that we'll see later, but this is the fundamental, this is the most important concept that you'll ever hear or ever would have learned about machine learning or artificial intelligence. And it is very important to understand how this machine learning algorithm or the cost function is optimized and other minimized, and it is then the learning algorithm, whatever is the learning algorithm, it learns. Okay, so thank you for watching this video. I hope you guys liked it. Please subscribe and like the video, and in the next video we'll be talking about linear regression, and in detail we'll see the linear regression with gradient descent, and we'll understand with example, we'll understand like how the optimization is happening and what are the other ways through which we can do the linear regression optimization. Okay, so that's all for today. Thank you guys.